Okay. There we go. Okay. The computer's been giving me a few issues today just with slowness, so I apologize for that. All right, so before we get started into the actual first lesson, okay, that was weird. I see him freezing a little bit too. Hopefully this thing works itself out. Okay, I think we're good to go, guys. Okay, again, welcome to our first actual math class here. I just want to make sure, I think someone sent me a message about not being able to get in. Come on. Just going to send a link here to a student. Okay. All right, sorry about that, everybody. And before we start with content and get into lesson 1 here, I just want to make sure if you have any questions about anything yesterday from the orientation or when you're going through the D2L shell, if something didn't quite make sense, you couldn't find anything, feel free to ask those questions right now. And if not, we'll just get started. Yeah, go ahead, Myra.
I did send the assignment we have for our favorite thing. I just was wondering, should we add our name on the page or in a comment, or how do you want to do that?
Oh, you don't need to leave a comment or anything. Some students will leave a comment in there, but you just need to upload your file and send it. You don't have to write anything in there.
Okay, I don't have to add my name or anything like that?
No, because once you submit it, it'll drop into the Dropbox and it'll be under your name already, so I know it's going to be from you.
Oh, okay, got it. Thank you.
Yeah, you're welcome. Okay, any other questions? Yes, Siada or Sita?
When is the due date? Friday, from what time to what time?
For what are you talking about? For an assessment or for my favorite thing?
Yeah, for assessment, drop it in the Dropbox.
For the my favorite thing in the orientation?
No, no, the other Friday, every Friday we have assessment. Yeah.
Yes, yes. Am I saying your name right, by the way?
Yeah, Saida.
Saida? Okay, gotcha. I will go into detail here because I just put in the assessment for the numbers quiz that will be this Friday.
Mm-hmm.
This is the one I was talking about yesterday. If you were in the orientation or if you watched the video, this one will be due on Friday at the end of the day. So it'll open at 8 in the morning on Friday, and it will close at 11:59 p.m. So at night, yeah. So once you open it, it's not going to take you long to do. It should take you about half an hour, maybe an hour tops. So as soon as you open it and start it, make sure you complete it within that hour. So don't leave it open all day.
Mm-hmm.
So complete it as soon as you open it, get it done, and then you can submit it right there. And this one is not for marks. So most of the questions are multiple choice. I think there's one or two where you have to type an answer in, but it's not where you have to type math and you just type in like a number for your answer, like 35 or something like that. Okay. So this will open on Friday at 8 and close at 11:59.
You can print it and then write down and then take a picture and can submit it and put that Dropbox, okay?
You won't need to do that with this one. Because it's multiple choice, you literally will just click the correct answer. You'll select it in the quiz itself. Okay. You won't need to take pictures with this one at all. You'll start doing that next week.
So only in the computer answer the question.
Exactly. Yeah.
Okay, thank you.
And I just put this in the calendar, you guys. You might not have seen it yet. So I just did it before class. So it's about 5 or 6 multiple choice questions. And like I said, 2 where you just have to type in the answer. It's like a numerical response. You'll be graded on it right away. So you'll see how you did on it, but it's not going to be a mark that goes into your actual grade feature. So it won't count for the course. It's just, again, just getting used to the quiz feature, how to use it, that kind of thing. And you won't have to use the Adobe Scan app yet for this quiz either, because you can answer by using multiple choice. So the Adobe Scan app will come into play starting in our January 22nd quiz here. And I will definitely review before that day how to do the quiz, how to put it on the paper, take the pictures, and then how to submit it. So don't worry about that until next week. Okay, I just want to make sure I'm not missing any questions here. Sure, yeah, I can talk about My Favorite Thing, Jonathan, definitely. I'm not sure if I've had any submissions of that yet, but I think I have it open for a little bit of time. So I'm just going to view it as you guys would view it. Okay, so you would go into content here. And then the weekly guides, we want to go to week 1, which is the only one open for you right now. And it's in course orientation here. So once you've gone through all of this part here, that's the survey that some of you have completed. I think 6 people have completed already. So if you haven't already done that, make sure you go in here. Again, it's using the quiz feature in D2L. So really easy questions. It's just getting you used to using that quiz feature. That's all. And here's My Favorite Thing. So once you've downloaded the Adobe Scan app and you watched the tutorial on how to use it, this is a video here. Let me go back. This is the tutorial on how to use the Adobe Scan app, this one here. And then this one here, this next video walks you through how to submit an assessment through D2L. So definitely a good one to watch. It will show you how to use Adobe Scan and to submit your assignment. But for My Favorite Thing, again, it's just getting you used to the process. So all you have to do is grab a piece of paper, anything you have around your house, draw something on it. We just said maybe draw your favorite thing, because a lot of times when you ask somebody to draw something, you sit there and you're like, well, what do I draw? So anything you want to draw, sun, a tree, a house, whatever. It doesn't have to be anything spectacular. Use your Adobe Scan app to take a picture of it and to convert it into a PDF. And this is the Dropbox right here. So you can click right on this. It will take you right to it. And right here it says add file. You would just select that. And then if you have it saved to your computer, you would just select my computer, you go ahead and find your file and download it. And then you would just hit the submit button right here once it's up there. You don't have to leave a comment. If you would like to, you could say this is just here's my picture of my favorite thing. Some students will write something in here, but really you just have to put the file in and then click submit. Okay, another way to get to this my favorite thing Dropbox, if you didn't go through the weekly guide, you can go right up here to assessments, the drop down arrow, and select Dropbox. And then my favorite thing will be up here. You just click onto that. And then the exact same screen. So you just click add your file, find your file where it's saved in your computer there. So you just go upload, find whatever file it is. This is now my computer documents. And then you would just click open once you've selected it. And then you would hit add, this add button here. And then it would have it uploaded there, ready to go, and just click submit. Oh, interesting, Bo. Okay, did you watch the tutorial on it? Okay, maybe try, you can always try whenever something glitches, right? Sometimes what I do is I'll delete the app and then re-download it. It might be a glitch in there. So maybe try that and see if that helps. Okay, perfect. And let me know if it doesn't. All right. Any other questions, anybody? Perfect. Okay, looks like we're good to go. So before we pop into D2L here, I'm just going to remind you, for those of you especially that weren't able to make it to the orientation yesterday, I'll show you where that video is if you need to rewatch it or if you haven't seen it and you'd like to watch it. Okay, so you just find our team, so into our Math 10C course here. And where it says 2 hidden channels, if you click on the arrow here, this said something different yesterday. I had named it class meetings and recordings, but just talked about yesterday how there'd be too many recordings to try to organize in there. By the end of the term, it would just be too hectic for you guys to find anything properly. So I changed this to just the welcome and orientation class. So if I click on this, so 2 ways you can find the meeting or the actual recording. So this is the original post. This was the time that we met. If you click on where it says the replies here, it opens up everything. So all of our conversation we had during it, but the very first thing will happen is you'll have the recording up here. So that's it. So you can just click on the ellipsis here and you can open it in Microsoft Stream. It will take you online to where the video is, or you can just click the video here and watch it. And I've also, because sometimes that's challenging to try to find it when you have to open up a big feed and scroll down. If you go up to the taskbar up here at the top, it says posts, files, and it says 2 more. Drop down menu, this is the class, this is the recording here. So you can click on it here too, and it will open it and actually play it right here in Microsoft Teams for you. Okay. So this video today, once we're done our class, the same thing will happen. This is our current class. It says join because we're currently meeting. But at the end, wherever you always look for the replies, where it says right here below the little purple Math 10C Week 1 classes, if you click on the replies, it will open it for you. There's no recording here yet. It just says the class has started because the recording hasn't been finished yet. So it will pop up right here once it's done. But what I'm going to do is I'll add a tab up here again for it. So you can just look for it up here in the taskbar. and I'll just label it like Tuesday, January 12th. And you can click on it here and watch it right in the Microsoft Teams. So that's where that will be. Okay, let's get into D2L here. So again, just a reminder, your first quiz, that's not for grades. Just a self-assessment will be on Friday this week. So that will open at 8 a.m. and close at 11:59 p.m. So you have the whole day to pick a time whenever you have half an hour or an hour here or there just to get it done. And then our first actual assessment will happen next Friday. And if I go into my weekly guides here, week 1, we're going to focus on lesson 1 in the workbook today. Lesson 1, prime factors. We'll do lesson 2 tomorrow. Lesson 3 will be Thursday, and lesson 4 will be on Friday this week. Okay, if you don't have your workbook yet, which is probably the case for quite a few of you, because that's what happens at the beginning is we aren't able to get into the college, so you need to get things delivered to you. So it might take a little bit of time. In the meantime, so you don't fall behind, there's the first unit is up here, numbers and exponents, at the very bottom of the table of contents. So if we click on that, these are the workbook lessons here for you for the whole first unit. So the lesson we're going to look at today, lesson 1, is in here, and lesson 2 tomorrow's is also in here as well. So if you want to follow along, for the most part today I'm following with the workbook. And I will do that mostly every day. I'll pick some things here and there, but I might add different questions in, or do some different types of word problems and things like that that aren't in your lessons specifically. But this is where you would find it. And the assignment questions will be right at the end of the lesson. So that was the first lesson. There's up to 6 examples, and then here's the assignment right here. And then there should be an answer key at the end. Yes, right here. So once you've done your assignment, you can go to the answer key and check your work. Okay, and it's a lot of printing. So if you don't have a printer, you don't want to print and waste the paper, just have this up on your computer, right? You can write down the question on your own paper, on your workbook or whatever you're using, and you can do the questions in there. And then once you actually get your workbook, you'll be able to write in there when it's in front of you. So for now, that's what we've got going. Perfect, okay. So this is how I'll run the lessons mostly. I'm gonna do some notes and things like that on a Word document. So I'll write right on the screen here. So if you want to take notes, you can. This will also be recorded too, so you'll see this if you're watching the video. So if you're not writing down notes, that's also okay, but you'll have to sift through the video, try to find which question you want to see. So sometimes writing things down and keeping things with you is beneficial. Okay. So in your numbers chapter, if you go to the very first page almost in your workbook, if you have it in front of you, is your table of contents. And I've just basically typed out the lessons in the first chapter. So our first unit of the course is going to consist of the first and second chapter in the workbook. So the first chapter is called Numbers, and the second chapter is called Exponents. And the Numbers chapter itself has 7 different lessons in it. The Exponents chapter has 6 different lessons in it. And at the end of each chapter, there's a practice test, which is really nice to use for review for your unit tests or your quizzes. Okay, so for the most part today will be some review of vocabulary, and then we're going to move into do some prime factorization. And you may have done this in a previous math course, depending if you took Prep Math 10 with us or somewhere else, and you might not have if you're just coming back after being out of school for a bit and you're jumping into Math 10C. So I'll make sure I do some background review with you as well. Okay, so let's get started here. So the very first thing that your workbook is going to go through is a bunch of terminology. And that's usually the case in the beginning of a unit. And even in beginning of lessons, they'll always put definitions throughout, which is really essential. Because those of you that have taken math before, especially like the word factor, any math term is usually also just a regular English term if you're in humanities or you're a social studies class or you're in a science class, you're talking politics or something like that. The word factor has a different meaning depending on what context you're speaking about it in. So you're going to see a lot of English words that you would know when you're from your English classes that are in math, and they mean something completely different. So the word factor here, and just if you want to follow along in your book, this is literally on page 1, right after the table of contents. So we're starting off at the very beginning. Okay, so just a reminder of what a factor is in math. And what that is a number that divides into another number evenly, which means there's no remainder when you divide it. So if we look at this first example here, it says find the factors of the following numbers. So what that means is you want to find all the numbers that divide evenly out of 8, 18, 27, and 36. So this might be going back a little bit for some people, but when you're doing factors, 1 is a factor of every number, right? I can do 8 divided by 1, it's equal to 8. It gets me a whole number back out. I can do 1,000,000 divided by 1. I can do negative 267,000 divided by 1. So 1 is always a factor. The next number I can divide out of 8. If it's an even number, you can always divide an even number by 2 to get a whole number. I can also divide 8 by 4, and this sometimes is forgotten, but the number itself is also a factor. So you can divide any number by itself, it always gives you the value of 1. So 8 divided by 8 is equal to 1. And those are all the factors of 8. 3 doesn't work, so if I do 8 divided by 3, I get a decimal. If I try 5, 8 divided by 5 gives me a decimal. Same if I try divided by 6 and divided by 7. So you only want the numbers that when you divide them, you get a whole number with no remainder or no decimal as an answer. Okay, 18, always start with 1. It's an even number, so 2 definitely divides out. 18 is also divisible by 3. Okay. 18, we can't do 18 divided by 4. That'll give me a decimal. Same with 5. But 6 will work. 7 and 8 will not. 9 will work. If you try 10, 11, 12, 13, 14, 15, 16, 17, none of those will work. So 18 will be the last one. Okay, so a lot of this we'll just know by looking at that. You'll remember basically your multiplication tables for these numbers. If this is something that's a bit tough for you, and that's totally fine if you haven't been in doing math for a bit, I'm taking the number 18 in my calculator and I'm just going divided by 1 equals. And it gives me a whole number 18, so I know that's a factor. Then I try the next number, 18 divided by 2 equals. It gives me a whole number, so that's a factor. 18 divided by 3 equals. It gives me a whole number, so that's a factor. So you can always do that if you need to. The only thing is if you get really big numbers, that will be very, very time consuming. Okay, so just make sure you practice with your multiplication tables if they're a little bit rusty for you. Okay, 27, definitely 1. It is not even, so 2 will not be a factor, but you can try it in your calculator to make sure. 3 is a factor. 4 and 5 won't work. 6 won't work. 7 doesn't work. Neither is 8. The next one will be 9. Nothing else will work besides 27. Okay. Another way to do this is we can make a different type of list if you're having a hard time. If you don't want to sit and go like 27 divided by 10, 27 divided by 11, 27 divided by 12, 27 divided by 13, and you have to check all the numbers 1 through 27. What we can do is, instead of writing a list this way, is I can do 1. So 27 divided by 1 we know is equal to 27. So 1 and 27 are a pair, because if I multiply them together, it gives me 27. 2 won't work. 3 does though. And I get 3 and 9. Okay, and then I would only have to try the numbers up to 9, because I know if I try 9, it's going to give me 3 as an answer, so I already have those covered. So if I do 27 divided by 3, it equals 9. That gives me the second factor there. Then I only have to try 4, 5, 6, 7, and 8. And if you try all of those, none of them will work. And once you reach 9, well, I know I've already covered 9 with 3 here, and nothing in between 27 and 9 will work because this was my next pair. Okay, so I'll do that with 36 because it gets a little bit challenging here. So 36, we definitely know 1 and 36. Okay, if I do 36 divided by 2, we get 18. 36 divided by 3, 12. 36 divided by 4 will give me 9. 36 divided by 5 won't work. 36 divided by 6 will give me 6. So right there, as soon as I hit a number that's the same value, that means you can stop. We've got all of our numbers in here. So the factors of 36 would then just be, you wouldn't write 6 down twice, you would just write 1, 2, 3, 4, 6, 9, 12, 18, 36. Okay. And I will stop every so often just to make sure or see if there's any questions. So just for the sake of the recording, for it to be nice and smooth for people that can't make it to class and need to watch it, try to refrain from just jumping in and asking questions. Wait for me to stop at some point and I'll definitely give you a chance to jump in and ask something. Or you can always write a question in the chat and I'll come back and check Microsoft Teams this page here every now and then to make sure I haven't missed something. Find that method of finding factors? Yes, Jonathan, that will work for any number. Perfect. Okay, any other questions? You're welcome. Okay, perfect. Okay, whoops. Let's jump into the next one here. So I'm kind of following along with the workbook lessons, but I'm using different numbers in here just to give you a different questions to practice with. No, Monica, so perfect. Yeah, just exact question I was just talking about. So no, the examples will be a little bit different. Your workbook is the same. So you're fine. I'm just using different numbers because there are videos online on the D2L shelf for this exact class examples in the workbook. So if you want to go and watch those exact examples, you can watch the videos on D2L. Some of them I'll do the same, some of them I'll do a little bit different, but I'll always kind of follow with the same theme. But your book is right. You're welcome. Okay, so the next question says, determine the number of factors of each of the following. So if you have your book in front of you, this is similar to class example 2. I just picked some different numbers in there again. So determine the number of factors. So I'm going to do what we did up in the example above. So if we look at 5, always start with 1. So 5 divided by 1 would give us 5, so that would be a pair, 1 and 5. So now because I have 5 written down, I only have to check the numbers between 1 and 5 now. So if I did 5 divided by 2, doesn't work, 3 doesn't work, 4 doesn't work, 5 does, it gets me back to this same pair, because 5 divided by 5 is 1. So those are the only factors for 5. So it asked me for the number of factors, so we would have 2 factors. Okay, for the number 1, definitely 1 divides out. And if I do 1 divided by 1, as you know, the answer is 1. So there's no other numbers in between 1 and 1 to check. So we only have 1 factor because we don't write the same number down twice. So 1 has 1 factor. Okay, 21 will be a little bit longer, not too much though. So 21 divided by 1 is 21. 2 won't work if you try it. If you do 21 divided by 3, that will work. So now I just have to check the numbers between 3 and 7. So you can try 4, 5, and 6. None of those 3 numbers will divide out of 21 evenly. So there is our 1, 2, 3, 4 factors. Okay, 13, 1, and if I divide 13 by 1, I get 13. So I only have to check the numbers between 1 and 13 now. So if you go ahead and try, or just think mentally to yourself, 13 divided by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, none of those will divide out of 13 evenly. So 13, just like 5, only has 2 factors. $25, we've got 1 and 25. 2 won't work, 3 won't work, 4 won't work. 25 divided by 5 though, that will work. And as soon as you get a number like this, just like the 6 and 6 up here, I don't have to check any more numbers because there's nothing between 5 and 5 to check. So I'm just going to rewrite this one because we don't want to write the 5 down twice. So it's 1, 5, and 25. So 25 has 3 factors. And then 29, we'll have 1 and 29. So I have to check all the numbers between 1 and 29. And this is where it gets a little bit painful because there's nothing else you can really do here, but if you need to check them, unless if you know already that 29, that's it, that's all it's got. But if you check 2 through 28, none of those numbers will divide out of 29. So just the 2 factors. Okay, questions on that at all? Okay, perfect. So that was just talking about factors only. So factors are all numbers that divide evenly with no remainders out of whole numbers. Now we're going to talk about prime numbers and composite numbers. So things you would have heard at some point in the past, but you might be a little foggy with it, and that's completely fine. So a prime number is a whole number which has exactly 2 factors. And these 2 factors are always 1 and the number itself, so whatever number we were talking about. So if I go back up to the question we just did, prime numbers have to have 2 factors only. So if I look at 5, 13, and 29. They have just two factors, and what the definition says is these two factors are always 1 and the number itself. So 5 factor is 5. 13 has 1 and itself. 29 has 1 and itself. So those numbers are called prime numbers because they only have two factors, 1 and themselves. So examples of prime numbers, the ones we just used, 5, 13, 29. Okay, all other numbers, besides there's two special cases, are called composite. So a composite number is a whole number which has more than two factors. So it has to be more than two factors. So 21 has more than 2 and 25 has more than 2. Oh, what are they? Now, of course, I forget what they are, 21 and 25. So there's much more composite numbers than there are prime numbers. And then there's the two special cases. The number 1. So a lot of speculation or a lot of debate has gone on in the math world about whether 1 is a prime number or not. Because when you think about it, it has the factor of 1, which is also itself, right? 1 is 1. But the definition says it has to have two factors. So 1 has to be one of the factors, and then the other factor has to be the number itself. Because 1 only has one factor, it's actually not a prime number. And when I look at composite numbers, it definitely doesn't have more than two factors, so it's not composite either. So 1 is neither prime or composite. So one special case. The number 0, so the number 0 is interesting. It depends on the course that you are in. Because as you move up in levels of mathematics, things get more and more complex, and you start to learn things where maybe you only learned half of the truth, that they call it, in earlier math courses. So you learn things kind of in sections. So with regards to this course, the workbook is telling us the number 0 is defined to have no factors. Okay, so 0 has no factors at all. In actuality, it has infinitely many factors because I can divide anything out of 0, right? I could do 0 divided by 1, it gives me 0. 0 divided by 300 gives me 0. So they all work. Anything you divide out of 0 gives us the answer of 0. But in this case, just makes things complicated because it doesn't follow the definitions particularly for a prime and composite number. So we're just going to say it has no factors. It's also neither prime nor composite. Okay. So list the first 10 prime numbers. This is at the bottom of that first page there in your workbook. So because we know that 1 and 0 both are neither prime or composite, it wouldn't go on our list of prime numbers. A lot of people also think that prime numbers are always odd. And interestingly enough, they are all odd except for 1. The very first prime number is the number 2. Right, because the factors of 2, if I did the factors of 2 over here, I can take 1 out of 2, so 2 divided by 1 is 2. And that would be it. There's nothing else between 1 and 2 to check, so it's got two factors. One of them is 1 and the other one is itself. So 2 is actually a prime number. All other prime numbers will be odd. So 2 is prime, 3 is prime, 5, 6 wouldn't be because I can divide 2 and 3 out of 6, including itself and 1, but 7 would be prime. 8 is not because I can divide 2 and 4 out of it. 9 is not because I can divide 3 out of 9, including 1 in itself. 10 is definitely not prime. 11 is prime. 12 is not, but 13 is. 15 is composite. 16 is composite. 17 is prime. 18 is composite. 19 is prime. I'm just going to count. I've got 1, 2, 3, 4, 5, 6, 7, 8. 2 more. 20 is composite. 21 is composite. 23 would be prime. It would only have 1 in itself as factors. 24, 25, and 26 are all composite. So is 27. So is 28. So the next one will be 29. So the way I think about this, if I'm doing it too quickly for you, but as I go through from like 23 up to 29, if I think of 24, all I'm looking for is there any other number I can divide out of 24 besides 1 and 24? Even numbers except 2 will always be composite because I can divide 2 out of them, including 1 and itself. So you can always skip even numbers after 2. Those will be composite. It's the odd numbers you have to think about. So with 25, the other number I can divide out of 25 besides itself and 1 is 5. So that makes it composite. 27, I can divide 3 and 9 from that. So that makes it composite. 28's even, so that's obviously composite. And then 29, if you think about it, there's nothing else that you can divide by 29 except for 1 and itself. So it might take you a little bit just to get used to this way of thinking again, but take your time. Don't feel like you need to be fast at this. I can only go through it really quickly because this is what I do for a living, so I do it all the time. So don't feel like, oh no, I'm behind, because you're not. As long as you know the rules and you're able to work through it, if it takes you a bit longer, that's totally okay. Okay, so if we flip over to the next page, for those of you following along in the workbook, if you then have questions, I will ask you, okay, now you know what a prime number and a composite number is. Classify these specific numbers. Now I can give you any number and ask you, is this prime number or is it a composite number? So remember the rule with even numbers. It makes things very easy for you. As soon as you see something even that's not 2, that's a composite number. Because 38, no matter anything else that can come out of it, I can definitely divide out 2, which means I know this for sure without having to check that those 3 are factors, and that automatically puts it into the composite domain. So 38 is composite. 23, we just listed up here, but you would just have to think, can I divide anything else out of 23 besides itself and 1? And the answer is no, so this is a prime number. 44 is even, so automatically I can take 1, 44, and 2 as factors. So that's composite. And then 107 is not even, so I can't automatically assume it's composite. And it's actually a prime number, so if you sat down and tried to figure out, divide everything 1 through 107 out of it, nothing will work. So 107 is prime. Okay, I'm just going to stop there and see if there's any questions about prime numbers, composite numbers, factors in general. Okay. Yeah, good question, Jonathan. If for bigger numbers, there are rules. Yeah, exactly. Besides going through all 107, which would take you quite a bit of time, hey? Turns you right off from wanting to do any of this. There are rules, and I'm actually going to find the document for it because I don't remember a lot of them. But there are rules for, obviously with 2 being a factor of any number is if it's even. with 3, it has to do with the last 2 digits, I believe, if they're divisible by 3. 5 is, you can divide 5 with a number if it ends in a 0 or 5. And then I think with bigger numbers, if you add the digits together, so if I add 1 and 100, 1 and 7 together, so 1 plus 0 plus 7, it gives me 8. It's an even number. So 3 is not divisible by 8. 5 isn't divisible by 8. 6 isn't divisible by 8. You could try 4. So you would try 107 divided by 4 because 4 is divisible by 8, but you'll notice it doesn't work. So there's definitely a way to pare down the amount of numbers you need to check. And I'm going to find that document for you, and I'll post it in D2L so you can see it. But for the most part, once we get past this lesson and move into further into math, you won't usually be asked big numbers like that. If they're prime or composite, we usually deal with smaller numbers. But in this unit, because you're just learning it, you might have to work with big numbers. So I will find that sheet and I'll post it and I'll review it with you guys tomorrow. Okay, good question. Yeah, for sure. Okay. So now that we've talked about what a factor is, what a prime number and a composite number is, we're now going to put 2 of them together and talk about prime factors. So a prime factor is a factor of any whole number, but that factor itself needs to be prime. So it can be a little bit confusing, even though it's a short sentence, because there's a lot of words in there, a lot of meaning in there. So for example, if I listed the factors of 9, so if we did 9 over here, we would for sure have 1, and then 9 divided by 1 is 9. If you try 2, it doesn't work. If you try 3, it works and it gives you 3. So because I have 2 numbers that are the same, I can stop there. So my factors of 9 would be 1, 3, and 9. We just don't write the second 3 in there. And then out of those 3 factors, the prime factors of 9, you'd have to look at those numbers individually and just list the ones that are prime. So 1 is not prime. 3 is prime. I can only divide it by itself in 1. 9 is not prime. 9 is composite because I can divide it by 1, 9, and also 3. So the prime factors of 9 would just be 3. Okay, so it's still factors of the numbers. You still have to find the factors, but then once you have the factors, you look for which ones of those are prime. And that's what prime factors are called. So there's something called prime factorization. And this is the process of expressing a whole number as a product of its prime factors. So if you remember, product in math means multiply. So when it asks me to, for example, express 9 as a product of its prime factors, well, we just figured out up above there that the only prime factor of 9 is 3. So I have to then figure out, what do I multiply 3 by? That's a prime factor of 9 to get 9. And it seems a little bit, that's a confusing question, but you multiply it by another 3. So they both have to be factors of 9. And then they have to multiply together to give me 9. So 3 times 3 is equal 9. So this is called the prime factorization, when you write the number as a product or a multiplication statement of its prime numbers. And small numbers like this, we can probably just do in our heads. Like if I said, what's the prime factorization of 4? Well, if I find the factors of 4, it'd be 1 and 4 itself. And the other number I can divide out of 4 is 2. And that gives me the same number out. So my factors of 4 are 1, 2, and 4. Oops. So if I had to write 4 as a product of its prime factors, the only prime factor is 2. So 2 times another one of those 2's would give me 4. So that's the prime factorization of 4. for the most part, you'll be asked bigger numbers than just 1-digit numbers or even 2-digit numbers. A lot of times you get 3-digit numbers. In this lesson, it actually gives you some questions about thousands and things like that as well. So it's a bit of work when you get bigger numbers. And there's 2 different methods that the workbook goes through, but I know that there's more methods that you can search online if you don't like the 2 I'm going to show you here. So feel free to search online if you find something that you like better. As long as it works properly, I'm completely okay with that. So the 2 methods that we're going to talk about today are the tree diagram. And I just put in here, this is the method I like best. So when I'm teaching, I usually stick with the tree diagram, but I will also show you the division table and you can choose which one you want to use. Both work just fine. It's just going to come down to a preference thing for you. So when it says, for example, so we're going to find the prime factorization of the following number. So I gave us a bunch of examples here. And these numbers are going to be different from what's in your workbook, but it'll be the same process in there. So you're going to want to watch the videos for the workbook examples too, so that you get those. So I'm going to start with a smaller number, which is 24. So I'm going to do both methods for these, and then you can pick which one you like. So for the tree, what we're going to do is we're going to start with 24. And it's a tree. It's called a tree diagram because we use branches to find different factors of the number above it. So with the tree diagram, you always start with 2 branches coming off from the original number. And all you have to do is pick any 2 numbers that you know that multiply together to give you 24. And it doesn't matter which 2 numbers. It doesn't have to be the same as the ones I use or the same as your friend uses. As long as you have 2 correct numbers that multiply to 24, your answer in the end is going to be the same. So I'll show you what I mean. I'll do 2 different methods and you can see. So let's say I think, okay, 8 and 3, right? Because 8 times 3 is 24. And then from there, I need to branch out from these 2 numbers too. So if I try 3, the only numbers that multiply together to give me 3 are 1 and 3. But because I want to find just the prime numbers only, I don't want 1 because 1 is not prime. So I can actually stop right here with 3 because 3 is actually a prime number. So what I tend to do is once I find a prime number, I'll circle it and there'll be no branches coming from that one anymore because that's one of the prime factors. 8, however, is not prime. So to get to 8, I could do 2 times 4. Okay, 2 is prime, so I don't want any more branches coming off of 2. I'm going to circle it. And then 4, I only have one choice, 2 times 2. And both those 2's are prime, so I'm going to circle all of those. So what this means is if I want to write the prime factorization, it would be all these numbers I've circled, these prime numbers multiplied together will equal to 24. Now you tend to group them, you do smaller numbers to bigger numbers. So all the 2 should go together. So I would do 2 times 2 times 2 times, I've got 1, 3. And we'll just double check that this works. So 2 times 2 is 4, times 2 is 8, times 3 is 24. So once you write that statement, always double check that it actually equals the original number. Because a lot of times these branches will get really big, and if you don't use the circle method like I do, sometimes you'll lose a number in the branches here and there when you're trying to read your work. So you can leave it written like that, or we can simplify this by going, okay, there's 3 2's. So 2 times 2 times 2 is the same as saying 2 cubed, and then times 3. So that's the prime factorization of 24. Okay, I'm just going to show you, I'll just write this down, but I'm going to erase it because it's going to be the same, it'll look the same in the end as my first tree. But let's say I didn't start with 8 and 3. So 2 other numbers I know that multiply to 24. Well, we could use 4 and 6. You could also use 2 and 12. The only combination you don't want to use is 1 and 24. You never want to use 1s because 1's not prime. So any other numbers is fine. 4 and 6 both are not prime, so I can continue on with those. 4 is 2 times 2, and 6 is 2 times 3. Those numbers are all prime, so I end up with 2 or 3 2's again, and 1 3. So if I wrote it out, it would look the exact same as this here. So, like I said, it doesn't matter what numbers you start with, just as long as you have the correct numbers that actually multiply together to give you the number above it. Okay, so that is the tree. The other method is the division table. So what we do here is we put the number here on top, so 24, and then we kind of do an upside down division sign. And I just need to find a number I can divide out of 24, but the key is for the division table that it has to be a prime number that you use always. This is why I like the tree better, because it doesn't matter whether you pick a prime number or composite numbers to start with. But with the division table, you always want to have prime numbers that you're dividing by. And always a go-to would be if it's an even number, use 2. I know for sure 2 comes out of any even number and 2 is prime. And then what we do is say, okay, what is 24 divided by 2? 12, and that answer goes there. And then you do the whole thing over again. So I want a prime number that divides out of 12. Again, it's even, so I'm safe. I know I can go with 2. You could choose 3 there, and that's completely fine, because I can do 12 divided by 3 or 12 divided by 2. And 12 divided by 2 would give me 6. Okay, same thing again, because 6 is not prime, so I have to keep going. So any prime number I can divide out of 6. Again, it's even, so I'm going to go with 2. 6 divided by 2 gives me 3. And I can stop now because 3 is prime. So there's my 3 or 4 prime factors of 24. So I got 3 2's again, and 1 3, so I'd write it the same. Or you could say 2 cubed times 3. Okay. If a question just says, excuse me, to find the prime factorization of the following numbers, either this or the simplified version works. But sometimes questions will ask you to write a number as a product of the powers of its prime factors. So as soon as you see the word powers in there, that means exponents. You'd want to write it in this way here, 2 cubed times 3. So just make sure you read the question carefully. Okay, I'm going to stop there before I do the next one, just to make sure there's no questions on either of those processes. So feel free to ask anything if you have a question. Perfect. Okay, we will forge ahead. So I'm going to bump up the numbers to be higher and higher because you got some bigger ones in your assignment that you need to get through. So 100. So if we do the tree with 100, it's interesting, didn't change color there. Tree. Okay. So again, why I like the tree method is you don't really have to think too hard. It's just I don't have to think, oh, what's prime that goes into 100? I can just go, oh, okay, well, 10 times 10. Right? You could do 2 and 50, so 2 times 50. You could do 5 times 20. You could do 4 times 25. So any of those routes are fine. The only one you don't want to use is 1 and 100 again, because you don't want to use a 1 ever in the tree. And then I've got 2 10s, which I can break up into 2 times 5 and 2 times 5. So both 2 and 5 are prime. So now I'm actually done at that point. So the prime factorization would be I'm going to group the 2's together. So 2 times 2 times 5 times 5. Or if you want to write it as a product of its powers, it would be 2 squared because there's 2 2's times 5 squared because there's 2 5's. Okay, if we use the division table, let's start with 100, and then my upside down division sign. So now I have to think of a prime number I can divide out of 100. Again, 100's even, so I can always just default to 2. 2 is prime, and it always divides out of an even number. So 100 divided by 2 would give me 50. Okay, 50 is even again. Another rule, however, is if a number ever ends in a 0 or a 5, we can also divide 5 out of it. I'm just going to switch it up and go with 5 here. So 50 divided by 5 would give me 10. And you can stick with 2 if you like. You'll just have a 25 here, and you'll have 5 and 5 come out after. You'll end up with the same numbers in the end. Okay. 10 is even, but it also ends in a 0, so I could use 2 or 5. So I'll use 5 again. 10 divided by 5 is 2. And 2 is prime, so I'm not going to do any more division. That's it. So I end up with the same thing. I've got 2 2's and 2 5's. Okay, so any method you like. Some people like the division table because it keeps things nice and neat and orderly. The trees, sometimes they get really long, takes up a lot of space. So it just, again, comes down to personal preference, what you would prefer to use. Yeah, so Stephen, good question. So you can use the exponents anytime. So if it just asks you for prime factorization, you can always use the exponent method. But if the question says write it as a product of its prime powers, if it says specifically powers in there, you have to then use the exponent method. But if it doesn't say it, you can use either or. Okay, let's try a bigger number. Let's do 369. So here's where you'll play around with your calculator a little bit, and here's where that those division rules will be helpful that I'm going to find for us. So if we do the tree diagram, $369. So I want to find any two numbers that divide or that multiply together to give me 369. Okay, so I just threw something in the calculator. I said, okay, 369 divided by 9. I picked something, and it happens to work because it gives me a whole number. So I can use 9 and 41. You could have used 3. You could have done 369 divided by 3, and you could have done 3 and 123, and then gone from there. Okay, so with 9, it's not prime. I can take 2 3's, but those are now prime. And now the challenge is 41. So 41 is odd, so we definitely can't take 2 out of it. So we could try 3, but if I add the digits together, 4 plus 1 is 5, and I can't do 5 divided by 3, so it's probably not going to work, but we could try 3. Doesn't work. So you can keep trying and trying and trying, but it ends up that 41 is actually a prime number. So this would be 3 times 3 times 41, or oops, 3 squared times 41. So either answer is acceptable. Okay, division table. This is where we have to use prime numbers to divide out. So I'm going to put 369 down and then the upside down division sign. And for sure, when I look at this, if all three numbers are divisible by 3, right, 3, 6, and 9, I'll definitely be able to take a 3 out of that. So if we do 369 divided by 3, we end up with 123. Okay, that's not an even number, so 2 is not going to work. But if I do add the digits together, 1 plus 2 is 3 plus 3 is 6. That means 3 should probably work because 3 can divide out of 6. And that gives me 41. And then 41 again, that's a prime number, so we would stop. And then you end up with the same solution as with the tree. Okay, just jump back over here, see if I missed something. Yeah, Stephen, so if you think about the more simplified, or I guess the more acceptable solution would be to always use the exponents. It just makes it look neater and nicer and more organized. So I tend to do that for sure. No problem. Okay, I think I've got a couple more for us. So I got 2 bigger ones. So we'll do 1,236, and then we're going to try 46,520. See how that goes. Okay, so if we do 1236 with the tree diagram, okay, so now everything's open for you. You can pick any 2 numbers that multiply to 1236. So that's where you can be creative if you want to think of it that way. Let's see, I just picked a random number and tried dividing it. So I used 6. So if I do 1236 divided by 6, we end up getting 206 as the other number. So 6 times 206 gives me 1236. Both numbers we can tell automatically they're composite because they're both even, and we'll be able to take a 2 out for sure. So with 6, we would break that down into 2 times 3, and both of those are prime, so I'm going to circle them. 206, because it's even, if you don't want to have to do any more thinking to try to find 2 different numbers, you can automatically just go with 2. And if I do 206 divided by 2, we're going to get 103. So 2 is prime. Now 103 is not even, so I can't take 2 out of it. And 103, if I add the digits together, 1 plus 3 equals 4. So 3 wouldn't work because I can't do 4 divided by 3. 5 won't work because it doesn't end in a 0 or a 5. 6 would only work if it's also divisible by 3, which it's not. I'm just trying to remember those rules. So if you're wondering what am I doing, again, I'll get that sheet for you so you can try it, or you'll know what the rules are, I should say. But the only number I would try here would be 4. It's probably not going to work because 4 is even. Yeah, it doesn't work. And then maybe 7, which doesn't work. So once I get you those rules, you'll have the exact key points to try, but 103 will be prime. So we'll actually stop there. So we'll get 2 2s, 1 3, and 103. Or we can write that as 2 squared times 3 times 103. Okay, division table. So 1236, upside down division symbol. So the number has to be a prime number we're going to use here. So if it's even, I can automatically go with 2. So 1236 divided by 2 will give us 618. It's even again, so we can always go with a 2. So it's 618 divided by 2 will give us 309. Okay, it's no longer even, so 2 won't work. My next go-to is always 3. So you can just try 3, or you can look at the digits and add the digits together like I was doing before. 3 plus 0 plus 9 is 12. And if that number, then when I add them together, if 12 can be divided by 3, which it can, then that means this number should also be divisible by 3. So we'll get 103, which is prime. So we'd stop there and say, okay, I've got 2 2s, so 2 squared times 3 times 103. Okay, and we'll just do the one more, this really big one. And once we're done this one, that'll be it for us for today. Okay, so if I do the tree diagram with this guy here, um, 46,520. There's going to be lots of numbers that work with this one, but if ever I'm in the hundreds or even thousands like this, if it ends in a 0, 5 will always work, but there's even a bigger number I can take out here. If it's in the hundreds and ends with a 0, 10 will always work. So when I'm working with the tree diagrams, I tend to try to use the biggest numbers I can so the diagram doesn't get really big. You could use 2 here because it's even. It just means that when you work down and keep going, it'll get to be a really big long tree, which isn't a big deal. It's just going to take up a lot of space on your paper. But if we try 10, so 46,520 divided by 10 just takes away that 0. So we actually end up getting 4,652. 10, we can keep going for prime numbers, 2 and 5. I'm going to circle those because we're done. Those are prime. Now 4652, so it's even. You can automatically take the 2 out, or you can try doing something bigger. So I'm going to try doing, let's try 4. So 4 works, and that will leave me with 1,163 when I divide 4 out of 4652. 4 is opposite. It can go one more branch, break it down to 2 times 2, and now we've reached prime numbers. Now 1163, because it ends in a 3, you might automatically think, well, 3 should work, but that's not how it works with 3. It has to be, when you add the digits together, that sum has to be divisible by 3. So 3 plus 6 is 9, plus 1 would be 10, 11. So 11 is not divisible by 3, so that won't work. Oops. 4 doesn't work, 5 won't work because it doesn't end in a 0 or a 5. 6 won't work because it's not divisible by 3. 7 doesn't work. 8 doesn't work. And even sometimes I get caught in this little string because I don't have those divisibility rules memorized completely. But even if you have those, there's still numbers in there that you have to check. So it's looking to me like nothing's going to work here. So probably a prime number. And a trick that you can always do too, that I will sometimes do if the numbers are huge, is you can just literally Google it. I don't write it telling you to Google things. Is 1163 prime? So use your resources for sure. Yeah, and it pops up right away. Yes, it is. So it saves me from having to go through and try to find numbers. So there we go. So we got 1, 2, 3. There's 3 2s times 1 5 and times 1163. And then again, just to double check, if your tree does end up getting really big, just quickly double check. So just type in our answer. So type in 2 to the 3 times 5 times 1163, and it should equal the original number. If it does, it means you didn't miss anything. If it doesn't, you might have missed a number up in your tree somewhere, one of the prime numbers. Okay, let's try this with the division table. So 46,520. Okay, so it's even, and we need to use a prime number, so I'm going to always resort to 2 if it's an even number and using the division table. So we're going to cut that right in half. 46,520 divided by 2 will give me 23,260, which again is even. So we can use 2, or you can use a 5 again because it ends in 0. I could have used a 5 at the beginning because it ends in 0. So either number will work. Divide by 2. 11,630. So I can use a 2 again because that's also even. Or you can use a 5 because it ends in 0. 5,815. Okay, so now it's no longer even. 2 won't work, but it ends in a 5. So 5 will work for sure. So divide by 5. That gives us 1163. And we already know from using the tree diagram that that's a prime number. So we've got 3 2s, 1 5, and 1 1163, just like our tree diagram answer. Okay. So when you're asked to do those questions, again, don't think you have to do both methods and show it all the time. I'm just showing you how to use both. And then from there, you choose what you like better and just use the one method. And then I would just suggest sticking with that method. Usually, like I was saying, as you move further into the course and as you move up into the 20 and 30 level, you won't be asked to find the prime factorization of a number like 46,520. They're just giving you big numbers now just to get you familiar with the process. But usually you're dealing with smaller numbers most of the time. And if you're wondering why the heck are we doing this, which is a good question, what this allows us to do eventually is once we move into radicals, questions with square roots and cube roots, we need to know this process to help us break down those numbers so we can simplify the radicals, which we will get into a little bit later in this unit. So if you're wondering why is this happening, there is a purpose for it that we'll get to a little bit later down the line. Okay, any questions on any of that? Okay, excellent. So I'm just going to jump to D2L here in case you're wondering what questions you need to do. So for those of you, again, that don't have the workbook yet, not a big deal. The PDF is posted on the D2L site for you. So you can either print just the assignment part, you can print the whole thing if you want. You can save it as a document to your computer, or you can just have it up in front of you and just work live right off the website and do all your work on paper. So again, where you find that is if you go into the content page, and go down to the numbers and exponents on the table of contents here, and the files, which is going to pop up for you right away. And it's this very first one here. So this will be both lessons 1 and 2. So today and tomorrow stuff. 3 and 4 will be Thursday, Friday. And then this down here we'll get into next week. Okay, and if we go into the weekly guides over here, and if I click on lesson 1, you may have already gone through this if you want to be a little bit ahead before the class, but there's some videos in here to help you work through specific aspects of it. There will be videos for each of the class examples in there specifically. So it will tell you in a checklist format what exactly you do when. And then it will also tell you what questions to work on. So there's your assignment questions there. If you don't want to do the entire assignment, these are the key numbers that we pulled out for you. But again, feel free to do all of them if you like. And then you'll have an answer key just at the very end there. You can check your work. Oh, okay, good question, Jonathan. So all the work you're going to do in your workbook day to day will not be submitted for marks. So that's just practice for you. It's your learning. It's to make sure you're going through the learning process, and it's so that you understand the concepts, so that when an assignment or a quiz or a project does come up, you've already done that background practice, so you know how to do the certain questions with it. So anything that's going to be handed in for me, that will either be available in a Dropbox once that gets opened up, or it will be a quiz. So all this day-to-day stuff is just going to be for you, just to work through on your own. Yeah, good question, because I tend to just assume people know that, but no. Anything in the workbook that you're asked to do day-to-day will not be handed in for work. It'll just be the quizzes, the projects, the assignments, which I will forewarn you about when those are coming up. Okay, perfect. Any other questions before I let you go today? Okay, just going to stop the recording.